Okay, in this video I'm going to go over something called edge detection. There's a lot of other videos on this, but I think this will kind of highlight some cool things you can do with MATLAB. And so basically what I'm going to do is I'm going to just download a edge detection image. Yeah, so this is a perfect one. So let's try and recreate this image on the left. Can we just get the image by itself? Yeah. Okay. That's fine. We'll pull this in and I'll just grab half the image. So let's see. So I'm going to put this over here for a sec. So there's I'm going to put it into image example. And so if I do ls, there is Q11JY. Okay, so if you watched my last video on image editing, if I want to pull this image in, I'm going to do original equals IAM_read, and what was that? Q1JJY, Q1JJY.jpg, IAM_show original. Let's see, did it like it? No, it doesn't exist. Did I type it in wrong? Can I not read? Q1J, oh, it's a PNG, my bad. Alright, boom. Okay, so there's my image. So I only want half of this because I want to essentially recreate this image. So I'm gonna grab. Let's see. I want to grab from on the X from 1 to 550. So I'm gonna say clipped equals original 1 to 550, comma all. And then I'm gonna do IAM_show clipped. Didn't like it. More than likely, I got the dimensions wrong, so it's probably all 1/550 like that. Boom. Okay, there we go. So now I've got my my image here. Okay. So now what we need to do is we need to do the edge detection algorithm, and I'm going to go over something called the Sobel operator. Okay, so a Sobel operator is a pretty complicated thing to do, but I'm going to break it up into a couple steps. So basically what we're going to do is we're going to convert the image to black and white. We're going to apply what's called a mask in X. We're going to apply another mask in Y. We're going to normalize the results of both masks, and then finally we're going to plot, well, yeah, that's fine, plot the result. Okay, so let's do this one at a time. Alright, so first let's convert the image to black and white. So if you watched my last video on this, basically what you do is you say black and white equals 1/3, and we got to do uint 8 times. And so you're going to take the clipped all comma 1 plus clipped all comma 2. Let me maximize this. Plus clipped all comma 3. Have enough? Okay, and then all of these need to be converted to doubles. Otherwise, you're going to overflow your thingy here. Okay. Let's do IAM_show original, and then let's do figure. We're going to show the clipped image, and then let's do figure IAM_show black and white, and let's see if that worked. Okay, so there's my black and white image. Why did I do that? If I do go to whose now, when I look at black and white is a 532 by 550. The clipped and original images are by 3, and so you can apply a mask to each color, but it's better to just do it like this. Okay, so now what we need to do, this is a really weird thing. What we're going to do is we're going to apply a mask in X. And so if you look down here, I've actually already written these codes. And so the mask that I want to do, here's my mask in X. I'm going to bring that over here. And so what this mask is, so I'm going to run this. And I'm going to type in mask X. Basically what that is it's this weird, so this guy Sobel, he created these masks, and so basically what we're going to do is we're going to go into this image pixel by pixel, and so this is a 3 by 3, so I'm going to grab the first 3 by 3 grid, and I'm going to multiply that 3 by 3 grid by this mask X. And then I'm going to add it all up, and I'm going to make that a pixel. And then I'm going to shift it one over to the right, and then one over to the right, and one over to the right. And I'm going to keep shifting it, multiplying these things in here, and save the result into the mask there. And then I'm going to get my result, and then that will be it. So you can probably watch other better videos on this, honestly, talking about like the actual machine science behind it, but I'm just going to go over how to code it in MATLAB. Okay, so basically the first thing we're going to do is we're going to do a double loop here. So we get a 1 to IDX of 1, 2, and let's get the rows and columns of black and white. So let's do a size of black and white. That'll give us the rows and columns of black and white. And so we're going to go 1, 2, and remember, we're not going to go all the way to the number of rows here. We're going to go to the number of rows minus 1. And the reason why is because when this guy, it's actually minus 3, right? Because when we get to the end here, this is a 3 by 3, and so we can only get to that coordinate minus 3. And so we're going to do the same thing, jdx equals 1 to column minus 3, like this. And I wonder if there's a way for me to like plot a box. Yeah, I feel like I should be able to do something like rectangle. So let's see if this works. I'm going to do a pause here, and I'm going to do a hold on, and I'm just going to make sure this works. So what I want to do is I want to make a rectangle, and let me just type in help rectangle. Okay, so we want position, x and y, the width and the height. Okay, so that's easy. So the position is just IDX, JDX, and then the width and the height is 3 by 3. So let's see if that worked. Let's see, it did not, too many input arguments. Help rectangle. Did I forget something? Oh, position, my bad. Okay, so let's grab position, copy, and then we're gonna do position there, boom, like that. Okay, so there it is. There is our little rectangle that we are applying the mask to. And so if I put this over here and I put this over here, if I hit enter, okay, that's annoying. Alright, every time I hit enter, we're moving that mask down, and I'm applying this mask to the entire image. It's a huge image. It's a lot of for loops. So if I hit Control C, maybe I can do a draw now, and I'm gonna do like a seal. I'm gonna do like a little animation, and I'm gonna do I am show black and white like this, and let's see if that just doesn't kill my computer. Oh wow, it's moving. Okay, yeah, it really didn't like this, but let's see. It looks like you kind of got it. I mean, you can kind of see. I don't know why the image itself is moving to the left, but you could see the image itself going over to there, going down. Okay, so I think this is working. There we go. Let's see if it throws an error when you get to the bottom here. No, it didn't. Okay, so then it just moved just to the right. Okay, perfect, cool. So basically, there's our rectangle. We can get rid of this draw now. So what I want to do is I want to make the output equal to rows minus 3, columns minus 3. Okay. What I'm going to do is I'm going to say out of IDX comma JDX is equal to the sum of mask X times my black and white square. And so I need to grab that black and white square. So where am I? This is equal to black and white of IDX to IDX plus, is it plus 2, comma, JDX to JDX plus 2. Okay, let's see if that worked. No. Okay, let's see. Integers can only be acquired with integer of the same class or doubles. Okay, so what the heck is black and white square? And then what's mask X? So what we need to do is we need to convert this to a double. So we need a black and white double equal to double black and white, like that. Okay? And so this is going to be black and white double. Here we go. Did it do it? Okay. So if I type in whose, I've got out. Okay, cool. So let's plot out. So out, I'm going to call this GX, and I'm going to do U in 8 of out. Okay? And I'm going to do figure IM show GX. Okay, here we go. Oof, that does not look good. Let me pause this for a sec, see what happened. Okay, I figured it out. The reason why it wasn't working is because the way we were applying the mask is wrong. And so if you look at like black and white square and then mask X, so if you do mask X times black and white square, what you're doing is you're multiplying the two together. But if you notice, -1 times 240 is not -960. Because what you actually want is you want this number times this number plus this number times that number plus this number times this number. So if you do mask X dot times black and white square like that, that will give you this. And so if you add them all together, you'll still get 0 in this case, but still the point is that it's 240 times -1, 240 times 0, 240 times 1, and then add up all the things together. And so if you do a dot times in here and you run this guy, I did some debugging down here, testing my old code. If you run this, there's the mask in the X direction. And so you can see that we're slowly getting there. So basically all we're going to do is now we're going to go get the Y mask. And so again, this is just a Sobel operator. Here's the mask Y, copy. And so I'm going to throw this, apply another mask in Y. And this is, I'm going to call this, this is fine actually. I can just copy and paste this exact code. Nope, I don't want to do that. I'm going to just copy this. I'm going to paste it in. And now I just need to go through and get rid of mask X. Don't need to do that again. Out. Don't need to do that again. This is good. This is good. This is a debugging thing. I can get rid of that. Debugging. Black and white square. Res. I want to do mask Y. And then I want to do GY. And then finally GY. Hit F5. And there we go. So now here's my mask in Y, and here's my mask in X. And so here are my two masks. And if you look, you know, this is like top right, and this is like top left. And so obviously if you add them together, we should get what we want, this here. And so now we're going to normalize the result. So let me just make sure that, let me do a whose. Let's see, GX and GY are doubles. So if I do G and I normalize it, that's going to be the square root of GX squared plus GY squared. Again, I'm going to notice that I'm using the dot operator. And then I'm going to do figure IM show G. There we go. That is pretty much almost identical to this guy that remember we downloaded this from the internet. You know, it doesn't look exactly the same. Honestly, I like mine better. You know, I mean, it's whatever. I mean, here's the original image. Here's the one we downloaded from the internet, and here's the one that I just made with my my own Sobel mask. So let's just do a quick recap here. This video is getting pretty long. We got the original image here. We show the original image. We clip the right half because when we downloaded it from the internet, it already had the Sobel image in there. Then we converted the image to black and white, just averaging the 3 RGBs. Then we had these masks, and these masks don't change. These are Sobel masks. If you Google this, you will find it. And then basically we just do a double for loop and multiply this mask by our image, and then save the sum of the result into out. And then we do the X the Y here on both, and I guess I'll leave it here for a sec so you can pause it and look at the code. And then finally we normalize both of the masks and then plot the result. So technically this should go up here, plot the result. And so I'm going to start up here and scroll down slowly so you can pause wherever you see fit. And I'm going to run the code one more time. So here's our full edge detection result. Here's the GY mask. Here's the GX mask. Here is the black and white image. Here is the clipped image. And here's the result that we got from the internet. All right, good luck.